Welcome to this explainer. Okay, so get this. Over a quarter of the entire global workforce is tied to one single industry. Today, we're going to fundamentally shift your whole paradigm of agriculture. We're moving way beyond that traditional image of manual farming and stepping straight into the reality of what it actually is, a highly sophisticated, high-tech engine of global commerce.
So let's just dive right into it. When I say the word agriculture, what instantly pops into your head, right? For a lot of us, it's a picture straight out of the past, a simple survival-based activity. Maybe a lone farmer tilling a small plot of land with some basic hand tools. But is that all it really is? Are we just looking at some ancient relic of human history here?
Well, scratch that, because the reality is totally different. We are looking at a massive, high-stakes agribusiness. Modern agriculture is this incredibly complex fusion of science, art, and commerce. And its ultimate literal task, sustaining 8 billion people on this planet. It has completely evolved from a basic survival strategy into an absolute industrial and economic powerhouse.
To get a handle on this, our roadmap for this field-to-factory explainer covers 6 quick stops: defining modern agriculture, the branches of agricultural science, the agricultural value chain, subsistence versus commercial farming, the drivers of productivity, and we'll wrap it all up with the systemic challenges and strategic solutions.
All right, let's jump straight into part 1, defining modern agriculture through what we call the triple lens.
To truly wrap our heads around this massive global ecosystem, we basically need a brand new mental model. Before we get into all its modern complexity, let's quickly look at the foundational meaning of agriculture by tracing its roots. The word actually comes from 2 Latin words, ager, meaning field, and cultura, meaning cultivation. It is quite literally the foundation of human civilization. But here's the thing, to manage the crushing demands of today's world, that simple foundational act of cultivating land had to undergo a massive strategic and professional evolution.
And that brings us to the definitions of agriculture, which we really need to view through a triple lens. First up, the scientific perspective. This is the rigorous, laboratory-grade management of natural resources to produce crops and livestock. Second, the economic perspective, where we look at agriculture as a global fiscal engine focused on pumping out raw materials and food. To make that tangible, just think about the cotton in the shirt you're wearing right now or the timber framing your house. It all starts here. And third, the general perspective, which is that foundational cultivation we all rely on just for basic human survival. So, the main takeaway here? This transition into a highly professional agribusiness isn't just a nice-to-have. It's an absolute strategic necessity to mitigate fiscal volatility and actually ensure our food security.
Which leads us to Section 2, the branches of agricultural science, or the 12 pillars.
Because of the crazy biological and mechanical complexities involved in large-scale production, agriculture is definitely not a monolith. To understand the true scope of agriculture, we have to break down this massive industry into its specialized pillars. It's really a highly granular ecosystem of 12 distinct branches categorized into 3 main functional groups. Think of it kind of like the different departments in a giant hospital or sprawling tech firm. First, you've got production and management, handling everything from agronomy and soil science to animal science and fisheries. Then you have scientific defense, which covers biotech, entomology, and plant pathology. And finally, you have structural support, so that's your engineering, economics, and extension services that basically hold the whole system together.
Now, the sheer importance of agriculture becomes crystal clear when we zoom in on those scientific defense branches for a second. Think about entomology, the study of insects, and plant pathology, the study of plant diseases. They act as the frontline medical wing of our national economy. I mean, if 30 to 40% of a harvest gets wiped out by pests, that is a massive direct hit to a nation's GDP and its export potential. These sciences are quite literally our frontline defense, protecting national revenue and keeping us safe from devastating food price shocks.
Moving on to Section 3, the agricultural value chain, tracing it from the field directly to the factory.
Once we've secured those rigorously protected raw materials, we enter the value chain. And let's be real, your everyday world depends entirely on the farm. Cotton drives the multi-billion-dollar global textiles and garments industry. Rubber, it's the absolute backbone of the automotive sector. Get this, without natural rubber tapped straight out of trees, the entire global aviation and automotive industries would instantly grind to a halt. Literally, there's no way to make airplane or car tires without it. Timber feeds all of construction and woodworking, while cocoa and palm oil are essential for food processing and cosmetics.
The supply chain resilience in manufacturing is completely inextricably linked to the stability of agricultural yields.
But here is where it gets really interesting. Maximum economic value is actually captured at the conversion point, which we call agricultural processing. You take a raw commodity like cassava or milk, you process it industrially, and you turn it into a high-value, shelf-stable finished good, like gari or cheese. Capturing these secondary margins is absolutely crucial for any economy. Without advanced processing facilities, a nation is essentially just exporting its cheap labor in the form of raw goods, only to turn around and be forced to import expensive value and finished goods. It's wild.
All right, Section 4. Subsistence versus commercial farming and bridging that massive scale gap.
When we look at the different types of agriculture, the scale of an operation completely dictates a nation's overall development potential. On one hand, we have subsistence agriculture. This is super vital for immediate family survival, usually characterized by small, fragmented plots, simple tools, and very low capital. But then, we have commercial agriculture. And this is all about market dominance. We're talking large-scale, consolidated production, like those massive cocoa or oil palm plantations, using intensive machinery and incredibly high investment. These commercial systems are the primary drivers of a country's foreign exchange earnings. And those earnings create the crucial fiscal headroom a nation desperately needs to go out and fund essential public infrastructure and education.
Which brings us perfectly to Section 5, the specific drivers of productivity, diving into the resources and factors.
So, how do we actually guarantee success in those massive commercial systems? Well, optimizing output requires the strategic coordination of 5 essential agricultural resources: land, labor, capital, technology, and management. Now, pay close attention to management here. Management is the absolute strategic nerve center of the whole operation. It's the vital coordinator that provides the oversight needed to ensure that your capital and your technology are actually being deployed effectively to maximize the output on that land.
But, even if you have absolutely perfect management, your productivity is still dictated by a variety of factors affecting agriculture. It's this constant, ongoing tension between physical factors, like the climate, soil type, topography, and water availability, and human factors. These human factors, or anthropogenic factors, meaning they're driven by human activity, include things like government policy, education, and transport. And this highlights a deeply frustrating systemic vulnerability. Transportation is the ultimate infrastructure bottleneck. Think about it. Poor rural road networks can completely neutralize advanced technology. The best laboratory-grade genetically optimized seeds in the world are utterly useless if the farmer can't physically transport that massive harvest to the processing plant.
Okay, final stretch. Section 6, the challenges and, more importantly, the strategic solutions.
Look, the problems facing agriculture aren't permanent roadblocks. They are basically just clear opportunities for strategic intervention. We need active solutions to agricultural problems. Got inadequate capital? We deploy specialized agricultural credit facilities. Dealing with poor roads? We aggressively push for infrastructure development. Pests and soil degradation? We roll out modern control and conservation practices. Low mechanization? We push for widespread, accessible technology adoption. These aren't just wishful thinking. They are actionable, strategic roadmaps for immense industrial growth.
And to actually implement those solutions, we rely heavily on agricultural extension. Think of extension services as the human bridge. Their primary job is to minimize information asymmetry. In everyday terms, that basically means bridging the gap so the brilliant scientific discoveries made in the laboratory actually make it directly into the hands of the farmers out there in the dirt. They're the ones who ensure that the massive return on investment from all that scientific research is actually realized on the ground through the successful adoption of new methodologies.
So as we pull all of these threads together, from the hardcore science to the global economics, from the dirt in the field to the massive processing factory, we are left with one critical directive. The mandate for the future is clear: we must achieve sustainable intensification. This right here is the absolute high-stakes challenge for human civilization moving forward.
Which leaves us with this final, incredibly provocative thought. How are we going to balance the massive commercial output required to fuel an industrial world of 8 billion people with the increasingly rigid environmental constraints of our planet? Agriculture is definitely not some dusty relic of the past. It is the single most critical variable in our collective tomorrow. Thanks for joining me on this explainer, and keep questioning the systems that sustain our world.